Assalamualaikum warahmatullahi taala wabarakatuh to Prof. Azhar. Today, our group we will presenting about a green solvent. Our group consists of myself, Muhammad Helmi, Nur Aziza, and Nadia Aziba. The vital roles of solvents play in the extraction process, particularly through the lens of the green chemistry. Solvent extraction is one of the most widely used techniques for isolating compounds from a natural sources, especially in pharmaceutical, food, and biofuel industries. The choice of the solvent does not just affect how much of the compound we extract, but also determines the safety, efficiency, and the environmental footprint of the process. Traditionally, solvents like hexane, methanol, and dichloromethane have been used due to their strong extraction capabilities. However, these solvents are petroleum derived, toxic, and very serious risk to the both human health and the environment. With the growing awareness of the sustainability and green chemistry, the need of the to replace the hazardous solvents with the eco-friendly alternative has been aware to the society. So what is exactly green solvents? The green solvents are extraction media designed to minimize harm and emit a minimal volatile organic compounds. We can group these solvents into four main categories. First is the bio-based solvents like ethyl, lactate, or limonene, which is made from plant-derived materials. Second is the water-based solvents, which are safe, inexpensive, and suitable for polar compounds. Third is the supercritical fluids. For example, is the supercritical carbon dioxide, which can be adjust its properties and ideal for the heat-sensitive materials. Last but not least is deep eutectic solvents or DES, which is a customizable mixture from the substance like choline, chloride, and urea. These solvents represent a shift toward a greener, safer extraction practices without compromising its efficiency and its performance. Regarding the efficiency, a green solvent is only useful when it is very effective. So in terms of efficiency, many green solvents match or even outperform the traditional or conventional extraction. For example, supercritical carbon dioxide, it is very selective and can be adjusted its properties to the target specific compounds. Bio-based solvents like 2-methyl tetrahydrofuran are also great at dissolving both polar and non-polar compounds. So the performance also can be evaluated from this picture: the extraction yields, economics feasibility, the solvent power, energy requirements, and selectivity towards the targeted compound. Next. Okay, regarding the sustainability standpoint, the benefits is very clear. These solvents are also biodegradable. It is be recyclable and also derived from the renewable sources. This can help to reduce our reliance on fossil fuels sources and cut down the toxic emission. Lastly, the green solvent also will allow us to conduct extraction that is very not only effective but also can align with the green solvents environmental safety and regulatory goals. So the goals for green solvents, we must ensure to meet all the requirement as the picture in this slide. For example, it is very low toxicity, it is biodegradability, low VOC, can be renewable. It also can be high solubility power, meaning it is very effective in extracting the targeted compound, and it is very selective, non-flammability, and it is very compatible to the extraction process. Also reduce the carbon footprints and meet the regulatory compliance. Over to you, Nur Aziza.
Okay, thank you, Helmi. Okay, let's move to challenges or barrier to adoption of green solvent technology. There is many barriers. First, is a limited solvent compatibility. Most of not all the green solvent may not dissolve or target analyte effectively. There is will issue with polarity mismatch, selectivity, or degradation of compound, and it's not universally suitable for all type of matrices or interaction method. Second, high cost. Okay. Some green solvent, particularly ionic liquids, bio-based solvent, and supercritical carbon dioxide are expensive due to complex synthesis or the need for high precursor. Additionally, they may not be readily available in bulk quantities, so if needed for industrial scale operation, and will cause the increasing the overall cost of production. And the challenges is a lack of toxicity and environmental data. Although it's labeled as a green, but some newer solvent like certain ionic liquids solvent is still lack in long-term toxicological and ecotoxicological studies. So this make regulatory approval difficult and increase uncertainty about their true environmental safety. Okay, I pass to Nadia.
So answering to Aziza's limitation and barrier of using green solvent, these are the potential solutions that we might use in the future. The first one is the using deep eutectic solvent as a potential solution to the limited compatibility. Due to the DES tunable properties, including the melting point, viscosity, conductivity, and also the solvating capacity, it is worth it to investigate the potential influence of these DES composition and structure on the extraction efficiency, selectivity, and also solute compatibility. For example, to extract polar compounds such as lignin, sugars, or polyphenols from lignocellulosic biomass in straw or wood, highly polar DES like choline chloride, urea, or choline chloride glycerol mixtures are often suitable because DES operate with solvent composition that will make it efficient to for its solvation capability. And then next is the build of recycling system. This is to answer to the challenges where there is high cost and availability of the solvent in bulk. So it is understandable that it will be costly to produce the bio-based solvent in bulk. Therefore, it is suggested to design solvent recovery and recycling system to handle larger volumes efficiently while preserving solvent quality and minimizing energy use. For DES, for example, DES, solvent recovery can be achieved through simple techniques such as solid liquid separation, centrifugation, or filtration after the recycling system. And then next is to establish guidelines for green solvent to answer on the challenges where there is lack of toxicology data. We could expand assessments on toxicology and biodegradability assessments by involving more pilot plant implementations. Because without like real pilot plant implementations, it is quite difficult actually to thoroughly assess the actual performance performance of green solvents, especially on its toxicology, low volatility, and also low VOC as claimed. Next is to create another example is probably to create a public database for green solvents performance, because current ones such as EcoInvent needs paid license to access. So this is actually quite niche and not really accessible to everybody. So it is like also a good idea to publicize and make it like open wide access to everybody, not just the industries but also to the to the citizen to be exposed more about green solvents. Okay, that's all for my part. Thank you.